Imagine a time when computers were as big as a room. A single machine needed thousands of glowing vacuum tubes, generating so much heat that they could warm up an entire building. These machines were slow, expensive, and often broke down. But everything changed with one tiny invention: the transistor. It's the small but powerful device that made modern technology possible. Before we dive into how transistors work, let's first understand why they were invented and why they matter. In the early 20th century, the world relied on vacuum tubes to control electricity in machines. These tubes acted like switches that could turn signals on and off, which is essential for radios, televisions, and early computers. But there was a big problem. Vacuum tubes were fragile, used too much power, and burned out quickly. If one tube failed, the entire system could crash. Engineers knew they needed something smaller, faster, and more reliable. That's when a group of scientists at Bell Labs started working on a revolutionary idea: a device made from a special material called semiconductors. In December 1947, three brilliant scientists, John Bardeen, Walter Brattain, and William Shockley, made history. They invented the first transistor using a tiny piece of a material called germanium. A transistor could do everything a vacuum tube could, but it was smaller, faster, and more efficient. This tiny invention could switch signals on and off, just like a light switch. But instead of using a glowing filament, it controlled the flow of electricity using semiconductors. This discovery would change the world forever. To understand how a transistor works, think of it as a water tap. When you turn the tap on, water flows. When you turn it off, the water stops. A transistor does the same thing with electricity. It can amplify a signal or act as a switch to turn circuits on and off. A transistor has three parts. 1. Emitter. Like the source of water in a tap, it releases electrons. 2. Base. This is like the tap handle. A small signal here controls the flow of electricity. 3. Collector. This is where the amplified signal goes. By controlling the base, we can control a much larger flow of electricity, making transistors perfect for radios, televisions, and computers. At first, transistors were used in radios and hearing aids, but soon, scientists realized something incredible. If you put many transistors together, you could build a powerful computer. In 1958, engineer Jack Kilby created the first microchip, where multiple transistors were packed onto a single tiny board. This led to the birth of the modern computer. Over time, engineers found ways to fit millions, then billions of transistors onto a single chip. Today, your smartphone has over 10 billion transistors working together. You may not see them, but transistors are everywhere. Every time you use a phone, browse the internet, or watch TV, you're using billions of tiny transistors. Smartphones. Transistors power the tiny chips inside your phone. Laptops and computers. Every processor inside a computer is made of billions of transistors. Cars and smart devices. Even your car's GPS and smart home devices rely on transistors to function. Without transistors, we wouldn't have AI, quantum computing, or space exploration. They are the foundation of all modern technology. So, what's next? Scientists are now developing quantum transistors that can process information in completely new ways. This could lead to computers that are millions of times faster than today's machines. From the giant vacuum tubes of the past to the tiny transistors of today, this invention has transformed our world. And as technology continues to evolve, one thing is certain: transistors will continue to shape our future. Thanks for watching. If you enjoyed this video, don't forget to like and subscribe for more amazing stories about the technology that shapes our world. Bye.